61, make sure when you convert that to exponential, it's 10 to the negative 1 there because you got to subtract the 3. You cannot convert until after you get the log by itself, and then you get 1/10 or 0.1, depending upon what you wrote there, but you end up with negative 49 over 20 or negative 2.49, something like that. 65, 5 and 2. Jacob, what'd you have?
I had 2 and 4.
Because I think you had a 0 here, didn't you?
Yes.
Yes. All right. And let's see, 70 should be 8 when you're done. 73, you get 2 answers, but one of them doesn't work. So you got to throw that out. And 74, you get an answer. I need to see negative 10 over 37, but you also have to tell me that doesn't work. Were you able to find it yet?
Yeah.
Okay. And then the last one was actually the one from class. So we already did that one. And Kayla still didn't do it right. Is that what you said? So 2/3 and 5/2. All right, we good there? All right, test tomorrow and Wednesday. I don't want that one. Okay. All right, just a little bit of an outline. Both parts will be 50 points. I'm just going to give you the background here. And I will go through a few here. Prove the product property in base 10. I promised you that. I want to deliver on my promise. Okay, I'll put that on there. And graph exponential log functions, including transformation. That is like the quiz. And so you will make sure you know they will all be base 2. So like y equals 2 to the x and y equals log base 2 of x. I won't give you like base 3 or 3 to the x or anything like that. Okay? They're all going to be base 2. Solving equations by rewriting the same base. So if I got 8 to the x plus 2 equals 4 to the 3x minus 1, that would be a case there. No calculator. Expanded and condensed form and evaluating log expressions, well, it'll look like this. Log base 3 of 1/9, and you have to determine what that is. So log base 3 of 1/9 would be negative 2. Okay, for that. True, false will also be on there, but those are all thrown in there. Throw a little true, false for you. Calculator part, I'll give you the following equations. I won't give you the half-life formula because I don't think you really need to memorize that to figure it out. You can just figure it out anyway. But those are just like on the quiz. Newton's law of cooling. Make sure there's a plus there. Some of you didn't put the plus there when you did a problem and it cost you. Compound interest, continuous compounding, exponential and log equations. Basically what we've done last week, Wednesday, Thursday, Friday. Okay. Application problems, Newton's law of cooling, and half-life problems, which were kind of a little bit of what we did Friday and Thursday. All right, let's take a look at a couple here. These are no calculator parts. So prove. All right, if you know it, write it down. If you don't know it, wait a half a second and I'll do it with you. Wait, you have plenty of time to memorize this.
That's true. I know the things.
Okay, this is what it'll say. Question number 1, front page tomorrow. Prove the log m times n equals log of m plus log of n. It'll say proof. I gave you the first step. I won't give it to you this time, but it's right here. Okay, let x equal log of m and y equal log of n. Let x equal log of m and y equal log of n. Got it from there, right? That's over tomorrow.
Gotcha.
Now convert to exponential form. We're just doing this in base 10. So you got 2 things that you need to convert. And that gives me 10 to the x equals m, and 10 to the y equals n. Remember, the answer to a log is an exponent, so that x becomes our exponent, that y becomes our exponent. Okay? So 10 to the x equals m, 10 to the y equals n. All right, you have this product, m times n, in our what we're trying to prove. So what we just do is we say m times n is going to equal. Well, m times n has to equal 10 to the x times 10 to the y. Okay. Now, what do you do on the right-hand side? Okay. Use your exponent rules. You get the same base, what do you do to exponents? Add them, subtract them, multiply them, add them. Okay, so it'll be mn, m times n equals 10 to the x plus y. So you can write it as one base. All right, now, that was kind of the key step. Convert to log form, or convert back to log form. All right, so think about what that would look like. There are 6 steps. There are 6 points to this word. You got to have every step. Okay, no, Josh, you can't just go from the first to the last and say, obviously, it's true. And so this is log of mn equals x plus y. Now, x equals log of m, y equals log of n, so we can replace. And we are done. So there's your 6 steps, including that very first one that I had written down. 1, 2, 3, 4, 5, 6. Okay. And then starting with there and ending with that final statement, the final proof. Okay. All right, everybody loves some good true false problems. So let's see what you come up with. There's 6 of them. I'll move it down here in a second. I'll let you examine it. See what you come up with. And I'll move it up a little bit more in a second. Hopefully you can see that last one. All right, Cooper, what do you got for number 1?
For number 1, I said false.
False. All right. Mia, what do you got for 2? And we'll take a look here, and we're gonna take a look here in a second. Adam, how about 3?
I said false.
False. Nathan, 4.
False.
False. 5. What do we got for that one? Emily? True. And 6. What do we got for that one? Peyton Burns?
I said true.
She said true. All right, let's see. False, true, false, false, true, true. All right, good work. Got them all right. Any questions on any of them?
First one.
First one. Okay, on this first one. This 2 can go to this x, so it would be natural log of x squared plus natural log of y. And then when you condense that, that has to be the natural log of x squared times y. To be that, it would have to be the whole thing would have to be in parentheses to apply to both of them. Since they're not both in parentheses, the 2 only goes to that first x, and so it's just x squared y, okay? Sorry.
Can you do 4?
4. All right, this one here, you got to remember the rule, which is that when you have a division, the log of m over n equals the log of m minus the log of n. So for this first one here, it would actually be log of 15 minus log of x. Okay, you have to write that, which would not be the same. You can't, when you're taking the log of something, you can't think of that as a distributive case. It's just log of that thing. So right there, for this to be true, it'd have to say log of 15 minus log of x, which is not the same as that. Okay? Others? Okay, good. All right, this again is a no calculator one. All right, this is one of those changing the base. All right, take a look at it. I'll do it here in a second. If you're good, go ahead. All right, now here, you got to take a look at each base and you got to convert it to the same thing. So 2, you can't do anything with, so just leave that. So to the 9 minus 3x times 4 can be written as 2 squared. 8 can be written as 2 cubed. And both of those are to their respective powers. The first one to the x plus 3, the second one to the 2x minus 1. Now remember, you got a power to a power, so you multiply those together. So this is 2 to the 9 minus 3x. This is 2 to the 2x plus 6 equals 2 to the 6x minus 3. All right, there on the left, how do you condense those? It's 2 to what power? Okay, 2 to what power? Jacob, what would I do here? What do you think? Do you remember?
Take the log of all of them.
No, you don't have your calculator tomorrow for this
Yeah,
one.
that's right. Okay. So can you just get rid of the 2 then?
In a way you can, but this goes back to what's x squared times x cubed that equals x to the what power? Fifth, what did you do to the powers? You added them, so I can take these 2 and I can do what with them? You can add them. So you take each of the powers and you add them together. And so that gives me negative x plus 15 equals 2 to the 6x minus 3. Now I guess you can get rid of the 2's. You're really setting the exponents equal to each other. Negative x plus 15 equals 6x minus 3. This is not going to be a nice answer. Just leave it as a fraction. No big deal. What do I get? I add x. I get 15 equals 7x minus 3. Add 3, and 18 equals 7x. X equals 18 sevenths. Josh, I'm sure you did not have to do all that work. You probably didn't have to do anything. So. All right, but that's how you do that. You get a fraction like that, no big deal. Just leave it as 18/7. Okay. All right. Let's solve this one. Josh, what's the answer? Would you give it to me, please? Round to 3 decimal places. All right. If you want, I'll do it with you here. I'll give you the answer. Hold on here. All right, that's what your search. If you think you're good to go ahead. I'll work here with you here and let you copy it down. But that's what you're aiming for. Yes, you can use your calculator on this one. Okay, yes, you can use your calculator. All right, that 4, dividing by that doesn't help. Okay, it's not going to give us much because you still got that exponent over there. So I'm going to take the log of both sides. So log of 4 times 3 to the 2x plus 3 equals log of 7 to the x. That's a product on the inside. Okay, that is a product. We use our rules and we can write it as a sum. That becomes the log of 4 plus the log of 3 to the 2x plus 3. And I still have equals the log of 7 to the x. And this is where, when I was looking at some of the homeworks, when it was more than just like an x in the exponents, and people made some mistakes. That 2x plus 3 goes out in front of the log of 3 as a constant. And so now it's, or a coefficient. So it's 2x plus 3 times log of 3 equals x times log of 7. Distribute this log of 3. And this is where I think I saw some mistakes. Log of 4 is here. 2x times log of 3. You can't multiply that 2 times that 3 or that x times that 3. The 2x just goes in front of the log of 3. So it's 2x plus 2x log of 3 plus 3 log of 3 equals x times log of 7. All right, you got to get everything with a log on one side, or not a log, everything with an x on one side, everything without an x on the other. I think the easiest thing is I would subtract 2x log of 3. That would be my easiest. So I get log of 4 plus 3 log of 3 equals x log of 7 minus 2x log of 3. All right, go ahead and factor your x out of the right-hand side. Pull that x out. And I get log of 4 plus 3 log of 3 equals x times log of 7 minus, okay, that just is 2 log of 3. Yeah, just x comes out. And I'll divide both sides by that. Now that other answer over there is the exact answer. I'm not going to require that on this test. I just need the decimal answer. What was that answer? And so when you type all of that mess in, hopefully we get negative 18.6. 3.1. And I would encourage you to double check typing it in because I saw some mistakes. It looked like you had the right setup, but you didn't get the right answer. Okay. Questions? Good? Issues? And all right, this is just kind of a little bit of a review. Don't worry about 76. And then I do have the answers on here. This is not going to be collected, but you do need to work on this till the end of the period. You do not need to put any exact answers, so just all decimals. These are all calculator. These would all be on the calculator portion of the test. Okay. You might want to review now your graphing. Like I said, that was on the quiz. Okay, if you have any issues with that. So for these, just list the decimal answer. And all right, here's those answers, and then you can really see those problems there as needed.